Hello and welcome to today's lesson, which is an investigation into electromagnetism, which is part of the magnetism and electromagnetism topic in GCSE Combined Science Physics. So in today's lesson we're going to look at an investigation which can investigate the strength of an electromagnet. So if we've been successful in today's lesson, we should be able to describe what an electromagnet is, understand how electric properties can change the magnetic properties of a material, investigate how the strength of an electromagnet can be changed, and we'll do this from the GCSE Combined Science specification for AQA in 6.7.2.1 Electromagnetism. In particular, being able to explain how a solenoid arrangement can increase the magnetic effect of the current. So in this investigation, you are going to change the number of coils in an electromagnet and see how this affects the magnetic field strength of the electromagnet. So in this investigation, you would need a power pack, wires, crocodile clip, insulated wires and paper clips. Now, what we need an electrical wire from the practical kit, and this wire is insulated in plastic. We will then measure out 1.60 meters of the electrical wire using rulers, ensuring our ruler was held straight and the wire was taut. When we get to 1.60 meters, we cut the wire and we ensure that the ends of the wire are exposed, as this allows us to ensure an electrical current will flow through the wire. Now, if the ends of the wires are not exposed, we must strip the wire with the wire stripper, ensuring we use the stripper section of the component and not the cutter section. You would then retrieve an iron bar from the practical kit and you would wrap 10 coils around the iron core. Now when you do this, ensure the coils are spread out and not touching each other, and that they can take up as much of the core as you want. Now when you have completed this, ensure you have your following arrangement. You will then get 2 wires with crocodile clips and you connect them to a power pack which has a set to 5 volts DC, and when this takes place, you then connect those 2 wires to the electromagnet cable, and as a result you ensure that the wires are held tightly and you've now got an electromagnet. Now this electromagnet will get hot over time due to the energy dissipated due to resistance, so it's important that when you're not using the electromagnet it is turned off. So when you get your electromagnet, you can then ensure that you have the same value in this particular experiment for your current by setting the power pack to the same value. So you could set it to 5 volts. So if the potential difference is the same, the current will be the same through the electromagnet. Now the value of the current can affect the strength of the electromagnet, so it's important you keep it constant. You would then retrieve approximately 50 paper clips. Now the paper clips are made from iron, a magnetic material, and the iron paper clips will always be attracted to the electromagnet because of this. So you will pour the 50 paper clips into a pile on the desk, and you've got to remember that each time the iron paper clips are attracted to the electromagnet, they become induced magnets. So over time this can affect the results produced because the paper clips would actually be attracting each other. So then to start the experiment, you would retrieve the electromagnet you have set up previously. You would then place the electromagnet into the middle of the pile of the paper clips. Now like we said before, because the paper clips are made from iron, a magnetic material, the iron paper clips will be attracted to the electromagnet. Now it's important to note that the poles of your electromagnet tend to pick up the most paper clips, since this is the place with the highest magnetic field strength, as you have the most field lines present. So you should place the electromagnet in a pile of the paper clips for the same amount of time and then lift the electromagnet up. Now this should be approximately 10 seconds as shown in this particular diagram. You then count how many paper clips are on the electromagnet, including paper clips which are attached to other paper clips. Now the more paper clips picked up, the stronger the magnetic field of the electromagnet. Now to reset the experiment, you must turn off the power pack and ensure there are no paper clips on the electromagnet. You would then repeat the experiment 3 times. You would then change the number of turns on the electromagnet. So you do for 20 turns, 30, 40, 50, 60 and 70 turns or coils, and you repeat each value 3 times. Now in theory, the position of the loops of the wire should not affect the magnetic field strength of the rod, and each time the paper clips should be gently tapped to remove magnetism from them, or a new set of paper clips should be used each time to reduce this induced magnetism effect we discussed earlier. Now the resolution of your results is determined by the size of the paper clips. The smaller the paper clips, the higher the resolution of your results. Now when you've gathered your results for the different number of paper clips picked up for the different number of coils in your electromagnet, you will then plot this graph with the turns of the wire going on the x-axis and the amount of paper clips picked up on the y-axis, and you therefore have a graph such as the following. Now in theory, if you carry out the experiment correctly, you should gain the following results. Now you'll notice a few things here. You should notice that firstly, as the number of turns of coils on the electromagnet increases, the amount of paper clips picked up by the magnet increases. This tells us that when the number of turns on the coil of electromagnet increases, the magnetic field strength of the magnet increases. Now because you are plotting a straight line through the origin, this tells us that the number of turns of the coil on the electromagnet and the strength of the electromagnet are directly proportional. Remember, direct proportionality is shown on a graph with a straight line through the origin. So what do we know about electromagnetism? When a current flows through a conducting wire, a magnetic field is produced around the wire. The strength of the magnetic field depends on the current through the wire and the distance from the wire. If you shape a wire to form a solenoid by coiling it, that increases the strength of the magnetic field created by the current through the wire. The magnetic field inside the solenoid is strong and uniform. The magnetic field around a solenoid has a similar shape to that of a bar magnet. Adding an iron core increases the strength of the magnetic field of a solenoid, and an electromagnet is a solenoid with an iron core. And you should be able to, in particular from today's lesson, explain how a solenoid arrangement can increase the magnetic effect of the current. So if we've been successful and learnt in today's lesson, we can describe what electromagnetism is. We can understand how electric properties can change the magnetic properties of a material, and you can investigate how the strength of an electromagnet can be changed. So I hope you've enjoyed today's lesson on the Electromagnetism Investigation, which is part of the Magnetism and Electromagnetism topic in GCSE Combined Science Physics. Thank you very much for listening and have a lovely day.